All right, this is a problem where we're going to find the extrema and the inflection points for this function here. Now, if we want to find the extrema, we're going to actually take the first derivative of this function. And then to find the inflection points, we're going to take the second derivative of the function. So let's start by taking the first derivative. If we take the first derivative of x to the fourth, we get 4x cubed. We just move the exponent to the front, subtract 1. And then same thing with x cubed, that'll be plus 3x squared. And then minus 6x when we take the 2 times the 3. And then the 1 goes away. So that's the first derivative. Now the second derivative, we do it again. So we take 3 to the front. That is now 12x squared. Bring the 2 to the front. That's 6x minus 6. Okay, now once we find the first derivative and the second derivative, we want to set them equal to 0. So let's go ahead and set this function here equal to 0. So 4x cubed plus 3x squared minus 6x equals 0. And let's go ahead and solve for x. So we factor an x out. That's 4x squared plus 3x minus 6 equals 0. So we know x equals 0, or 4x squared plus 3x minus 6 equals 0. Now we're going to have to probably use the quadratic formula here to figure out what are our roots for this function. And let's go ahead and do that. So the roots for this function are going to be, let's start with -3 plus or minus, right, negative b, root b squared, which is 3 squared, minus 4 times a, which is 4, times c, which is -6, all over 2 times 4. So that's what x is going to equal. Those are my roots. So when I go ahead and evaluate that, I'm going to throw all that in the calculator real quick. So we're going to get 9, and then I'm going to multiply all these together. So minus 4 times -6, 105. So I end up with -3 plus and minus root 105 all over 8. So that means I get x equals -3 plus root 105 over 8, or x equals -3 minus root 105 over 8. So my 3 possible local extrema would be, local and absolute extrema are x equals 0, x equals -3 plus root 105 over 8, and x equals -3 minus root 105 over 8. So this is for our extrema. Now, we might as well just go ahead and do this for the double derivative here. So this is to find our inflections and to see where our concavity is. So let's go ahead and set this equal to 0. So 12x squared plus 6x minus 6 equals 0. I'm going to just divide by 6. I think that'll make it easier. So it's 2x squared plus x minus 1 equals 0. And now we can maybe factor this. Let's see. If I try to factor it, I get 2x here. I'll get x here. I got to split this 1 up. Well, if I put the 1 here, a positive 1 here, I'll get 2x times 1. That's the positive 2x. If I put a -1 here, that'll be the -1x, and that'll give me my middle term, and then this gives me -1, so this must be the right factoring. So that means 2x minus 1 equals 0, or x plus 1 equals 0. So that means if I add the 1 and divide by 2, I get x equals 1/2, or x equals -1. So these are possible inflections. I'm going to go ahead and underline my extrema and my possible inflections. Okay, so now that I have all of this stuff, I need to go through and I need to check to see what my concavity looks like, which would be off our inflection points. I need to try and figure out the max and mins from the extrema. And in order to do any of that, I need to use some number lines. So let's do an extrema number line. And I'm going to go ahead and do that here. So extrema. And so I'm going to throw these on a number line. This is 0 in the middle. This is one of my, and I'm going to say roots 0, comma, negative, or plus and minus, well, negative 3 plus and minus root 105 over 8. So those are the different roots there. Okay. So I'm going to put 0 there. This is going to be a negative root. So I'm going to put this here, negative 3 minus root 105 over 8. And over here I'm going to put negative 3 plus root 105 over 8. Now I'm going to plug in a coordinate out here. I'm going to plug in a coordinate in here, here, and here to see what's this, what do these look like? Are they maxes or are they mins? So first of all, let's plug in and let's get a number for negative 3 minus root 105 divided by 8. So this is really equivalent to negative 1.65. And let's do the same thing. And this is 0.91. Okay, so now that I know what those numbers are approximately, I can figure out the numbers I want to plug into my function. So if it's negative 1.65, I'm going to plug in negative 2. I'm going to plug in negative 1. I will plug in 0.5, and I'm going to plug in 1. And I'm going to check to see, are they positive or are they negative? And that's going to tell me if it's increasing, because remember the first derivative is a slope, right? So it's going to tell me, is my slope increasing or decreasing? And if my slope switches from increasing to decreasing, that means I got a maximum. If it switches from decreasing to increasing, then I've got a minimum. So let's go ahead and plug all this in the calculator. Now I'm going to try and, I like to use my graphing calculator to kind of cheat on this. I think it's a good idea for you to do the same. So I can plug in negative 2 by using the store button and saying I'm going to store it as x. And then I'm just going to put that function in my calculator. So 4x cubed plus 3x squared minus 6x. All right, once I do that, I plug it in. It tells me I got a negative 8 for a slope in that area. So I can say that this area over here is negative. So then I can say, we're going to plug in negative 1, so I can just do negative 1, store it as x. I can go up, grab that function. It tells me it's positive. So this area in here is positive. I'm going to kind of circle these so that you see that's negative, that's positive. And then let's plug in now 0.5. So 0.5 stored as x. That's negative, so that's going to give me a negative right there. And then I can plug in 1 stored as x. Grab that function again, gives me a positive. So, what's that tell me? That tells me that I've got a decreasing slope up into this root, so it decreases to this root, and then all of a sudden it increases. That means this is a minimum. So I can say that negative 3 minus root 105 over 8, this is a minimum. This is increasing to here, or increasing to 0, and then it decreases afterwards, so I can say that 0 is a maximum. So I've got a maximum, which is 0. And then I've got, and I'm going to kind of underline these, I've got another minimum right here, which is negative 3 plus root 105 all over 8. So I've got two minimums and I've got a maximum. Now, the one thing that's nice about this is I can see that this function, it's going to go, this slope is going to go be negative forever toward negative infinity. So this slope just tails off here. This one goes positive and tails off this direction. So if this one is, this one's coming down from the top. Sorry, this is a negative slope coming down from the top. This one's positive going up this way. So what that tells me is I don't have an absolute max because these tail off. It kind of does like almost makes a W, because it comes down this way, then up, then back down, then back up. So it makes a W for a function. So that does tell me though that I've got two minimum values, and one of those minimum values is probably an absolute min. So I know that these are at least local. Let's find an absolute. How do I find the absolute? Well, I need to find which one has the lowest y value. So this one or this one is going to have a lower y value, and I figured that out by plugging into the original function. So let's go ahead and just plug in negative 3 minus root 105. Divided by 8. And then I'm going to say that this answer, and let's store it as, and actually I'm going to use a better button here. I mean, that works, but I'm going to say second answer and I'm going to say store it as x, and then I'm going to type in this whole function right here. So I'm going to say x to the 4th plus x to the 3rd minus 3x squared plus the 1. All right, that gives me a y value of negative 4.25. I'm going to write that down. So this one here has a y of negative 4.25. Let's look at the other one then. So negative 3 plus root 105. Divide that by 8. Let's go ahead and do second answer and store it as x. And let's grab that function again. That's negative 0.04. So this one is negative 0.04. Well, which one's lower? That one right there has the lowest y value, so my absolute min, is negative 3 minus root 105 all over 8. And I don't have, so there's no absolute max. So absolute max, none. There is no absolute max because remember this thing is dropping here, then going up, then going back down, then going back up. So there's no absolute max value because both ends are going to infinity. Now, that takes care of my local mins and maxes. I have to also in this problem state where it's increasing and decreasing. Well, if I want to state that, I just say that it's there would be decreasing from negative infinity up to this root here, which is negative 3 minus root 105. And it's also decreasing from 0 to this other root, -3 plus root 105. So I have this union, this spot. And then for increasing, I say between here, these two roots, union from this root to infinity. And then that's how I'd write my increasing and decreasing for that function. Now let's move on to inflection. And now that we're kind of in the spot, I'm going to slide this up a little bit, and we're just going to focus on the inflection part, which is this area here. Now remember, I'm going to probably still use that original function, but I'm just sliding up for a second so that I can draw my number line and check this function out. So on this case, I'm looking for inflection, or concavity. You can think about it that way. We're looking at concavity. Maybe that's a better way to put that, is to say concavity there. But I'm just going to write inflection for now. So this is -1. This is 1/2. These are the two numbers I'm checking. So I'm going to plug -2 in. I'm going to plug in 0, and I'm going to plug in 1. And I'm going to plug those into my second derivative equation to find out, is this thing concave up or concave down? Is it going to give me a plus or a minus? So again, I'm going to use -2, and I'm going to store it as x. I'm going to plug in that function, which is 12x squared plus 6x minus 6. Okay, it gives me a positive, so this is a concave up area. Now I'm going to plug in 0. You plug in 0 into this function. You don't even have to, I'm going to slide it down a little bit. Sorry, you can't see the function. But you plug in 0 into this function, and you're going to get a negative, and you'll see that here. I'll just store it real quick. So 0 stored as x, and you get -6. So you get a negative here. Now I'm going to do 1, store it as x, and click on that function again, and that's positive. So if it asks you where you're concave up, where you're concave down, well, you're concave up from -infinity to -1. And then for union that with 1/2 to infinity. That's where you're concave up. If it asks you where you're concave down from -1 to 1/2. Meaning, just like I said before, this function is going like this until it gets to that point, then it's going this way, then it's popping back up and going that direction. Right? So it's got two cups on the end and then a upside down cup in the middle, if you're thinking about cups or bowls. It also tells us that we have inflection points. We got an inflection point which is -1, we got an inflection point which is 1/2. So we have two inflection points. So I can write that inflection points. And my inflection points, I need to figure out the coordinates. So one of them is -1, comma something. The other one is 1/2, comma something. So I'm going to take that original equation, and remember, if I slide this over, the original equation is, and you can see this over here. Oh, we can fit it all on there. Very good. So the original equation is y equals x to the 4th plus x cubed minus 3x squared. So I need to find that y value. So I take -1 and I store it as x. Store it as x. And then I plug in that function again, which was x to the 4th plus x cubed minus 3x squared plus 1. That gives me -2 for a y value. So one of my inflections is -1, -2. Now I'm going to store 0.5 as x. Go back up, grab this. And I get let's do that math of fraction here. 7/16. And there are my inflection points. So now I know my concavities, I know my inflection points, I know my local maxes and mins, I know my absolute mins and absolute maxes. And I get that from taking the first derivative to find the extrema, setting it equal to 0, finding the roots, and then using a number line. And I do the same thing for the inflection, which is the double derivative, and that'll set it equal to 0 once you get the double derivative, find the roots, and then you can find out whether or not you have inflection points and check out your concavity. Hope this helps.